Welcome to another round of Which Hypothesis Test? Which error are we dealing with? Alright, so for this one, we have a company of large fleet of vehicles. They're hoping to keep gasoline costs down and set a goal of attaining a fleet average of 26 miles per gallon. I'm going to highlight that since I'm going to need it. To see if the goal is being met, they check the gasoline usage for 50 company trips, chosen at random, random, and finding a mean of 25.02 miles per hour and a standard deviation of 4.83 is the strong evidence that they have failed to attain their fuel economy goal. Okay, so I know it's evidence. Going to be doing a hypothesis test. I've got one mean here. I'm looking at one group here. I'm looking at the 50 company trips that they chose. There's only one group of trips, 50 company trips. So I'm looking at one group of trips, one mean. I've got myself a one sample t-test. Again, if I was dealing with proportions, it'd be a one sample z-test or one prop z-test. Since I'm looking at means here, I've only got one sample. I'm looking at myself a one sample t-test. So let's go through our null and our alternate here. Our null hypothesis, it says they have a goal of obtaining at least 26 miles per gallon. So I'm going to go with my null is going to be 26 mpg. For my alternate, out of that 50 cars, we're trying to prove that for the entire company, their goals they want to get less than 26. So to see if they're meeting their goal, they get an average. So I want to prove that our average is actually less than 26 miles per gallon. If they're trying to prove more, then I make it more. If they're just trying to prove that it wasn't 26, then I would do doesn't equal. But since they're trying to prove that they're hitting that goal of less than 26, that's why my alternate is going to be less than 26. All right, time for some conditions. All right, so for my conditions, random, let's see. Random, check, that's a condition. 10%, let's see. They checked company usage for 50 company trips. And it says a large fleet of company cars. So I'm going to go on the impression that for our 10% condition here, I'll write it down. 50 is less than 1/10 of all trips. Again, I'm just going under the assumption based on the information they gave me. Might not be true, but hey, based on what I've got, I'm going with it. And then the last one is large/normal. So we want to see if our sample size is greater than or equal to 30 or if it's normal. We've got 50. That's definitely greater than or equal to 30. So I have met that condition. My conditions are met. I'll just even stuff these up here. There we go. I am all set to run my hypothesis test now. All right, so what I'm going to do is I'm going to go up to my calculator. Still haven't nailed this yet. Figure I've been doing this long enough. All right, here we go. I'm going to go to stat. I'm going to go to tests. I'm going to go to t-test. That's what I'm going to be running here. I'm going to enter in the statistics I have. I'm going to enter in, let's see, I'm trying to prove 26 is my null. The average I got was 25.02. Standard deviation was, whoops, a little hard to read based on this, but 4.83. My sample size was 50. All right, now what am I trying to prove? I am trying to prove that it's actually less than this. So I'm going to go with this right here. First one here, this would be if they don't equal each other. This would be if I was trying to prove that 26 was greater than the actual average. And actually, I am trying to prove that. I'm trying to prove that 26 is actually greater than what the average is. So I'm going to go with that last one. I'm glad I actually thought my way through this. So, because we're trying to prove that it's less than 26. All right, so I'm going to go down. I think I got everything here. I'm going to go to calculate. Enter. All right. Ooh, I got pretty high p-value here. And actually, I'm glad I did this because now I'm seeing that it's trying to prove that the mu is greater than 26. That's not what I want. I want to try and prove that mu is less than 26. So I'm going to go back to this. Let's go back here. Delete, second quit. We're going to go to that. There we go. We'll try again. Test, t-test. All right, so 26, good. Everything's good here. I'm trying to prove that's actually less than the average. Good. I'm glad I'm doing this. It's good to walk through because a lot of people, they make this mistake just like I do. So this makes sense because I'm trying to prove that our average is actually less. So let's see what happens. We're going to hit enter, enter, calculate what happens. Good. So now we got that the average is less than 26. You can see it right up here. Probability that's actually less than 26. So I get my t is negative 1.43. And then my p-value, this p-value looks pretty realistic too. If you're getting something really, really high, it can happen, but you always want to double check if you're getting something really high. We still got a pretty high well, I hate to say high p-value, 0.07 isn't exactly high. The probability of seeing this statistic, if it actually is 26 that we're averaging, the probability of doing a random sample and getting 50 company trips that average 25.02, probability of seeing that is like 7%, which, you know, it's pretty low, but it's not less than our significance level, which is 0.05. So we have a case here since my p-value is, greater than, I fail to reject my hoe. All right, so what does that tell me? I don't have enough evidence to prove that that the cars are averaging less than 26 miles per gallon. So I'm going to write that. I don't have enough evidence to prove the cars average less than 26 mpg. Now, one important thing to clarify, that does not necessarily mean that I've proved my null hypothesis. I just don't have enough evidence to prove that it's not true. I don't have enough evidence to prove my alternate here, so I just failed to reject my null. Now, what kind of error could have happened here? Type 1. Reject the null when the null is true. That's type 1 and not type 2. However, I failed to reject my null, which means I could have made a type 2 error. What type 2 error is when you do a hypothesis test, if you fail to reject the null, when in actuality you should be doing that, that could be a type 2 error. So that could have happened here. Maybe those cars I got the samples from, again, the probability of getting that average is like 7%, which is still pretty low, but maybe it just had to do with the 50 that I chose. Maybe if I chose another 50, it would reflect that it actually is less than 26 miles per gallon. That's what we're looking at with errors here. Maybe the sample we did, we didn't get the accurate number. It's possible, but not super likely. Anyway, so here we go. This is how I determined it. I looked at it. What did I have here? I have one average from one group. So I have one sample t-test, set my null, my alternate, and I did make a small calculation mistake, but I went back and I fixed it. That's part of the process here. Being able to recognize that, hey, maybe I did something wrong. Let's go back and fix it. Hopefully this helps you.